Okay, welcome to this video. This is a review of circles, chapter 10. Almost there, almost done with geometry. So you have this review packet, and I trust that you've taken some time to try to complete as much as you can. Obviously the answers are in the back, but I wanted to make a video, not just because I like to listen to myself talk, or that I assume you'd like to listen to me talk, but instead just go over some questions. Even though you're not around, I'll just have to imagine some questions. So let's begin. Make sure you have your name at the top, so when you turn in your chapter 10 classwork, chapter 10 review, this packet, and chapter 10 homework, in that order, that I can follow everything and not mix them all up. So make sure your name's on your class notes and your review and your homework. So I'm not going to take time to do the multiple choice here. I'm not going to take time to do the problems here. Other than this first one, looks like it would be helpful to do. There are several formulas in this chapter that you should know. The equation of a circle is one of those formulas. So you have x coordinate minus h. H is the x coordinate of the center squared, plus the y coordinate minus k, which is the y coordinate of the center squared, equals r squared. If you didn't notice, this is in the form of the Pythagorean theorem, a squared plus b squared equals c squared, where c squared is r, the radius. So make sure you know this formula. Make sure you know this formula for your test tomorrow, or whatever day it is. There's a lot more other... there we go. This looks pretty crazy. Hopefully you had time to do this. A chord, there are a lot of options for chords. You could pick segment BD is a chord. You could pick EC is a chord. Mainly you just need 2 points, 2 endpoints of a segment that lie on the circle. JE is a chord, that's another one. And you just need to state one. Tangent line. Any of these, this line is an option. You got this line is an option. You got, oh no, not that line. You have to touch at exactly 1 point. So it looks like you have 2 options. You could say line GB. Make sure you use correct notation with a line on top of it with 2 arrows, or you could do AG with a line on top of it. Radius, we've talked about radii quite a bit, so hopefully you labeled that correctly. A pair of congruent segments inside the circle. Let's see. A pair of congruent segments inside the circle. Notice we have a perpendicular bisector here. We discovered that in the lab. So JF is congruent to FE because of the perpendicular bisector through the origin. Pair of congruent segments. Pair of congruent segments outside the circle. Remember when 2 tangent lines, when they intersect outside the circle, that would mean this segment and this segment. AG and GB are both congruent when tangent lines intersect outside the circle. Okay, that's enough of that. There's a lot of empty space there, isn't it? Let's see, name the center. Make sure that when you're stating center, you do the opposite. So the center is 2, -3, and the radius is the square root of 36. Since this number is r squared, the radius would be 6. And number 24 is going backwards, so you're given the information, you have to write the equation. Your answer should look something like this as your answer. I'll skip that though. If a circle has that center passing through that point, then the equation is what? You need the radius. The radius is the distance formula, and you can do the difference in the x's squared plus the difference in the y's, difference in the y's squared. So the radius would be the square root of 16 plus 2 squared is 20. So when you write your equation, it's going to be equal to the square root of 20 squared, which is 20. And the center you have is 4, -3, and the signs change That's a plus. So that looks like that answer. Given the circle center O and tangents are drawn, find the requested values ROS. ROS. So to find that, we know that these tangent is perpendicular to the radius, and then this is a angle bisector, so we have 11, 11. So we have to find ROP, measure of angle ROP. That would be 90 plus 11 plus the measure of angle ROP. So that's 101, so 79 degrees is one of them. 79 degrees times 2, since you have two congruent angles. So that sounds like it's 160 minus 2 is 158 degrees. I guess another way that you could have done it, seems like this might be something that Matt or Sam might come up with. I think they came up with this one time before. You have a quadrilateral, so you could add all the angles. You have a 90, you have a 90, you have a 22, and you have that missing angle, and they all would add up to 360 degrees. And that should give you 158 as well. So nice job, gentlemen, if you had that idea. PO, let's see, PO. You have radius of 2 for WO, and this radius would also be 2, OV. These are both 90 because the radius is perpendicular to the tangent line. So we can use the quadratic formula, 2 squared plus, or not quadratic formula, woo, Pythagorean theorem, 2 squared plus 3 squared equals OP squared. And you could solve that to find number 27. I really like ones like 28. It's kind of like a mystery novel or something. Find the perimeter. If this one down here is 10, that means that this segment is also 10. If this is 4, that means this segment is 4. If this is 6, that means this is 6, and this is 6, and then this is 8. That was actually kind of an easy one. Then you'd add all those up. Make sure you add them correctly. One thing you could do, if you don't like to add very much, you could take each number, well, not each number, each one is a pair. So if you just add up those and then double it, that would be the perimeter. So that would be 10, 20, 34, 34 double, since you have 2 4s, 2 6s, another 2 6s, 2 8s, and 2 10s. But that's just me having fun, so let's move on. Let's see. Oh, looks like my arcs are a little off. Maybe they're not off on your paper, but so we have a lot of given information. We even have an arc that's surprisingly below. There we go. So we have a lot of given information. You definitely want to label your circle when you have such a situation as this. So a measure of arc AB is 65 degrees. Measure of angle EAC is 80. EAC, I guess C is over here. EAC is 80. EAC is 80 degrees. So what I would notice is this angle is inscribed in the circle, so that means arc EDC, which I guess is a minor arc EC. That's going to be 180 degrees, so I'm just going to label that to remind myself. So what do we have first? We also have that made it easy for us. AE is congruent to AB. AE is congruent to AB. Okay, so if that's true, then you also know EA is 65, since congruent chords produce congruent arcs, so we know that much. And there's probably a lot more that we could label, but let's see what we're asked for. Measure of AE. AE, we already have that as 65, because we have congruent arcs on congruent segments. Measure of ECA. ECA, where's that? ECA, okay, so this angle over here, notice that this angle is inscribed. Maybe I'll do it in purple for Susie, since she likes purple. EAC. Here's the angle inscribed with this arc. So the arc is double the angle, so if you half 65, you would get the answer. So that angle would be, what's that, 30, 32, 32 and a half degrees. And make sure you're writing degrees on measures of arcs and measures of angles. You don't want to lose points for not including units like degrees. Let's see, ED, where's that? ED is up here. Well, you could notice, get rid of this, sorry Susie, get rid of that highlight right there. You could notice ED, you have a semicircle here, and 65 plus 65 is 130, so 180 minus 130 is 50 degrees, so measure of arc ED is 50 degrees. EOD, let's see, EOD. So this is a central angle. Central angles are the same measure of the intercepted arc. So that angle would be, ED was 50, that angle is 50. Measure of arc DC. Finally, I get to use that observation I made way at the beginning, that we have this inscribed angle right here. That right there. And the intercepted arc is all the way around there, which is EC, which is what we're asked for, and the answer to 33 is 160. Oh wow, you have some more. BC. BC is over here to let's see. If that's 50, you know, what we just found is 160. You know, EB is 50, so that makes this minor arc DC 110. And you only have one more arc left, so if you add them all up, you could subtract from 360 to get number 33. So that would be, let's see if I can do this in my head. 180 plus 110 is 290, so you need 70 more degrees to complete BC, 70 degrees. Sorry about the messy handwriting. And then CAB, 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 there we go. CAB is right here. And the angle is half of the arc. Half of the arc. So the arc we just found was 70, so the angle would be 30 degrees. On the next one, we have the relationship between ADB, this angle, and the intercepted arc. We've used that several times on the previous example. You know that the arc is double the angle, or the angle is half of the arc. So you're given that the angle is 60 minus x, and if you double that, so if you do times 2, if you double that, you would get the measure of the arc, which is 2x minus 16. So when you distribute, you can solve there. Add 2x to both sides, this becomes 4x, add 16 is 136, and divide by 4. And that solves for x. Let's see, ODH, ODH, that is perpendicular. You have a radius and a tangent line, so the answer to 37 is 90 degrees. DAB, DAB, notice that this intercepts this angle, intercepts a semicircle. Semicircle, the arc is 180 degrees, and then the inscribed angle is half of that, so this would be 90 degrees as well. So both answers are 90 degrees. Polygon inscribed in a circle, measure of angle B, and measure of angle A. So let's see. First thing that I think is maybe we could work backwards, and this whole arc right here is double 55, so that would be 110 degrees for the arc. And then this arc right here, double that, since angle C, DCB is inscribed, so double that, that would be 170. So that's that much. Actually, maybe we'll look at it this way. If you're trying to find measure of angle B, measure of angle B is this angle. Notice that the intercepted arc is the major arc ADC, all the way around. We know that this arc, from C to B to A, that's 110. So let's put this 170 on hold. You know that the rest of the circle is 360 minus 110, which would be 250 degrees. That's the remaining arc, the major arc ADC. That's also going to help you find measure of angle B. So if the rest around the circle, the rest of this is 250 degrees, measure of BC intercepts, or it's inscribed in the circle. So if you half 250, that would be 125 degrees. 125. You could use the same reasoning to find angle A, but it'd be much easier since it's a quadrilateral. The interior angles sum up to be 360, so you can add and subtract from 360. Number 41, CB, all the way down there. So we're given a bunch of perpendicular to each other, DM and AC. DM is perpendicular to AC, DM, so that's perpendicular, and then DN is perpendicular to BC. So we have a radius there, and it appears that we have congruent triangles, don't we? Those two triangles there are congruent because of hypotenuse leg. So that allows us to say that this measurement is also 8. And since those are perpendicular, this is actually from a lab. You have a chord, and you have a perpendicular bisector. So that means, things are disappearing on me. That means these two segments, playing games with me. Quit playing games with my heart. That means this segment is also 8, so 16 units would be the answer. Let's see, 42, OX. OX. So this is another perpendicular bisector, so this is also 7. This is a right triangle, so you can use Pythagorean theorem. X squared plus 7 squared equals 8. Whoa, equals eraser option equals 8 squared. So you could solve that and to find OX. Oh, on the next page, YX. I was hoping they wouldn't ask that. YX. How in the world are we going to find YX? Oh, YX. How silly. Some things are right in front of you, aren't they? So YX. This is a radius. BO is a radius. It's also something else. YO is a radius. So the answer is 8. They're both radii. Moving right along. There are a lot of circles in this chapter. CD. Where's CD? CD's right there. Notice that CD, you have an inscribed angle. The inscribed angle is half of the arc. So you would double 35 and get 70 for a measure of CD. This is really similar to one above, so I hope it's okay if I skip this and move on to another one. Something we haven't seen yet. BAC, measure of arc. Wait a second. Angle BAC. I think that's a typo. It should be BCA. Okay, now on to material that I have taught you via video. This right here, 48, should be BCA. BCA. So what you do is you add the two, 80 plus 30, divide by 2, and that's how you get 48. CB, you would add whatever measure of CB is, plus 35 divided by 2 equals 70 degrees. You double both sides and subtract 35 to solve. This one, inscribed angle, there are a lot of options for inscribed angle. Right angle. Right angle, it looks like you would have to say this angle, AED, not just because it looks like right angle, but because it is an inscribed angle that intercepts the circle at the diameter. So half of 180 would be 90 is a right angle. Arc intercepted, you could probably do that. Pair of congruent angles that are not vertical angles, you'd want to say that. You could probably figure that out, I think. So I'm just going to move on from there. And this part was sadly messed up. Very sad. I hope yours didn't turn out like this, but this is really crazy. Find measure of angle 1. Again, you'd add the 2 and divide by 2. It's an average. That would give you measure of angle 1. This one is the one we did directly above it. You would say x plus 35 divided by 2 equals 80 and solve algebraically. Now on this one, there's a proportion here, just to remind you what the theorem looks like when two chords intersect inside a circle. You have AE times ED equals CE times EB. So you have a proportion going on, get rid of that. You have a proportion going on, where was I? Right here. So you would say 20 times x equals 5 times 10. And you'd solve so you get 5 halves is x. This is very small, not drawn to scale. When two secant line passes, touches the circle in 2 points, you might remember from definition right here. Secant is any line that intersects the circle in exactly 2 points. The formula is right here. Remember, you have to do part times the whole equals part times the whole. So remembering that on this example, you do the 1 part 8 times the whole thing, 8 plus x, equals 10 times the whole thing, 10 plus 24. This example actually is taken right from your class notes. So if you need to see how to solve that algebraically, you can look in your class notes. Let's see, same thing for this one. Same basic idea. You're going to do 8 times 8 plus 14. The whole length is 8 plus 14 equals x times itself, which is x squared. And you're going to take a square root. You're going to get a positive and negative answer. You just want the positive answer since it's a length. And that looks like that's all. Sorry about this last page that was all kind of goofed up. Maybe it didn't happen on yours. Sorry about all those random things going on. Just sometimes randomly sad that I'm not there with you. And looks like arcs are often just randomly sad through the notes. See, there's another "where's Mr. Eicher when I need him" kind of face. Thanks for watching this video.